Welcome to the channel. So today I'll be explaining about normalized discounted cumulative gain. So what is this normalized discounted cumulative gain mean? So it is a metric that evaluates quality of recommendation and information retrieval systems. It compares rankings to an ideal order where all relevant items are at the top of the list. So from this paragraph what I am able to understand is, so this is the ideal ranking. You are able to see in the current slide that this is the ideal ranking. Ideal ranking in the sense here you are able to see the indications. See, not relevant are grayed out and relevant are marked with the red. So versus the real ranking, how it is going to happen. This is the ideal one and this is the real one. What it is happening means first are the grade 1 and then coming down we are going to find the most relevant document. So what is the formula which is associated with this concept? So NDCG at the rate K means how many K means for how many documents I need to find the discounted cumulative gain. So the NDCG at the rate K equal to DCG at the rate K by IDCG at the rate K. Now K parameters. So K indicates the number of documents means first 10 documents or first 5 documents for what. So here you are able to see these are non-relevant, gray one are non-relevant and remaining are relevant. Now cumulative gain. So gain means it is considered with respect to the relevance. So let it be binary or be it graded. So cumulative gain means it is sum of scores of all relevant items among the top K results in the list. So as you are able to see here in this K, a user is going to give a query, right? So once a user gives a query, it is going to compare with the documents which are present, and the documents which are going to match the user's query, like this here first document, third document, fourth document and all. So those scores, the we will assign the scores to all those documents and we will sum it up. So that is what you mean by CG, that is cumulative gain. For example, you have binary notion of relevance and out of 5 recommended items 3 got a click. So the cumulative gain of given list will be 1 plus 1 plus 3. If you have graded scores from 1 to 5 and all your top 5 recommendations got a 5 star, then the total gain will be 5 into 5, which is 25. Let's see here. For example, consider A, list A and list B. So list A, it consists of a user is gonna give a query, and according to that, first two documents are non-relevant. Remaining three documents are relevant. So this indicates that gain, the cumulative gain is going to be 1 plus 1 plus 1, which is 3. Suppose if you consider list B also, if you consider list B also, then the gain is going to be 1 plus 1 plus 1, which is 3. But actually, the second result is going to seem like a much better outcome because this is the idealized ranking which we saw. Uh, Here, you'll be able to see this is the ideal ranking, means the most relevant document will be occurring first and then the non-relevant documents are grayed out. Similarly, but this is the real ranking which is happening. So compared to list A, list B should have a better outcome. So the ranking often matters, having the most relevant results at the top be just what we expect. So therefore, we need to give credit to the system where it can place more relevant items higher and penalize it for placing relevant results lower on the list. Now, what is this DCG? We came across cumulative gain. So this is how we will calculate the cumulative gain. But what about DCG? That is discounted cumulative gain. So it is also one of the metric which is used for measuring the ranking quality. So discounted cumulative gain, in this concept we are going to introduce the discount. So which gives less weight to relevant items that appear lower. Means as we all know, we saw in the idealized ranking and the real ranking comparison. Though the documents which appear at the last will give the least discount and here will give the more discount. So that is what we are telling here. So discount it gives less weight to relevant items. Here we will give more weights to the most relevant documents, and as we go down we will give the less weights. So and we'll just, instead of simply summing up the items relevance, we adjust the contribution of each item. So this is the formula which we will use for calculating the discounted cumulative gain. So DCG at the rate K equal to summation K equal to 1 to K, means from first document to the kth document, relevance divided by log to the base to I plus 1. So now DCG computation. Suppose here you are able to see an example how we are going to calculate the discounted cumulative gain. So suppose we have a rank list with binary scores 1 0 1 1 0, and we want to calculate DCG at the rate 3. Means since we have considered k equal to 3, I need to calculate the discounted cumulative gain only for this one and this one. Means only first three items in the array. So we can sum the relevant scores of all items up to k based on this formula. So this binary scores indicates the relevance. So DCG at the rate 3 equal to, we are able to see here. So these three are like first document is relevant, third document is relevant, second one is not relevant. So 1 divided by log to the base 2, 1 plus 1, because since it is first document, so I will be 1, right? So 1 plus 1 plus 0. Why second document is 0? Since it is not relevant. So 0 divided by log to the base 2, 1 plus 2 plus third document is relevant. So 1 divided by log to the base 2, 1 plus 3. So 1 divided by log 2 to the base 2 is 1. So 1 by 1 is 1 itself, plus 0 divided by anything is 0, plus 1 divided by log 4 to the base 2. So 1 by 2 you will get, so which is 0.5. So let us add these results. You will get 1 plus 0 plus 0.5, which is equal to 1.5. So this is how we will be calculating the discounted cumulative gain. That means as and when the relevance of the documents to the given query goes on decreasing, we will start giving less weights to that. Now, if we change the order and put the third relevant item in the second position, now how will our DCG looks? So now discounted cumulative gain. In the previous example, we saw second document was not relevant. Now let me interchange these two, second and third. So DCG at the rate 3 will be 1 by log 2 log 1 plus 1 to the base 2 plus 1 by log 1 plus 2 to the base 2 plus 0 divided by log 1 plus 3 to the base 2. I told just now how did I get all these steps. So 1 plus log 3 to the base 2 is 1.585. So 1 divided by 1.585 plus 0 by anything is 0. You get 1.63. We are able to see here placing non-relevant document in the middle or first before the relevant document. I'm placing the non-relevant document at the last, how much the difference is there. So that is 1.6. If I place the non-relevant document at the last, it is going to be 1.63. If I place the non-relevant document before the relevant document, the DCG is going to be the less. Means here it is basically, for this example, it is going to be 1.5. So what is the limitation which is associated with this technique? That is discounted cumulative gain. Longer lists have higher potential DCG values since more items can contribute to score. DCG at 10 can be higher than DCG at 3 simply due to the length of the list rather than inherently better ranking. So this is not a better one. This DCG is not a better one because as we increase the value of k, of course the DCG value is going to increase. Suppose I have calculated DCG at the rate 3, I am getting 1.63. Suppose if I calculate DCG at the rate 10, definitely it is going to be more than this 1.63. So like that it should not happen. So whether I increase K or not, it should be able to fetch the most relevant documents and it should return me. So what should we do in order to alleviate the problem which is posed by discounted cumulative gain? So to alleviate that problem, we will come across a concept which is called as normalized discounted cumulative gain. So you are able to see here NDCG, normalized discounted cumulative gain. You must divide the computed discounted cumulative gain by the ideal discounted cumulative gain for the given list, as you have already seen here. So this is the formula. So NDCG at the rate K equal to DCG at the rate K divided by IDCG at the rate K. So what exactly is ideal? So in case of binary relevance scores, all relevant items should be at the start of the list. You have already seen here the ideal ranking. So all relevant documents are at the top and non-relevant documents are at the bottom. So in case of graded relevance, you should place all items in descending order of relevance. Now let's consider that a search engine that outputs 5 documents named D1, D2, D3, D4, D5 are output in that order. We need to define the relevance scale 0 to 3, where 0 means it is not at all relevant, 1 to 2 means somewhat relevant, 3 means completely relevant. So here this is also given by them itself, means this is also the question itself. So D1, D2, D3, D4, D5. So here I am considering k equal to 5. Okay, so when I'm considering k equal to 5, I have already explained what is cumulative gain. I'm just adding these values. So 3 plus 2 plus 0 plus 0 plus 1. So I will be getting cumulative gain as 6. So this is not that good actually. So now let me calculate the DCG. So discounted cumulative gain. So coming for discounted cumulative gain, you are able to see the formula, that is summation k equal I equal to 1 to n relevance score I divided by log I plus 1 to the base 2. So this is the steps I'm going to explain how did we come across this step. So DCG 5. 5 indicates number of documents. So 3 divided by log. Since I is 1, first document 1 plus 1 plus 2 divided by log. Here I it is second document. So 2 plus 1. So 3 plus. So here 0 divided by log 3. Since it is third document, I is going to be 3. So 3 plus 1, 4 plus 0. Like this, I will be calculating. I will come across this step. So let me go to the next step. So 3 divided by log 2 to the base 2 plus 2 divided by log 3 to the base 2 plus 0 divided by log 4 to the base 2 plus 0 divided by log 5 to the base 2 plus 1 divided by log 6 to the base 2. So 3 divided by log 2 to the base 2 is 1. So 3 by 1 I am going to get 3 plus 2 divided by log 3 to the base 2. So log 3 to the base 2 I will be getting 1.585 plus 0 by anything is 0. Put the same. 0 by anything is 0. Enter the same. Plus 1 by log 6 to the base 2 I will be getting 2.585. Let me simplify this. I will be getting 4.67 as the discounted cumulative gain. Now we need to arrange these articles in descending order. So according to the idealized discounted cumulative gain, what I'm supposed to do, as you have already seen before, that I need to place all the relevant documents at the top in the decreasing order, and the non-relevant documents should be put at the last. Okay, so when you are going to implement IDCG, that is ideal discounted cumulative gain, IDCG, I am going to uh, rank those cumulative gain scores in the decreasing order, that is 3 2 1 0 0. So IDCG also it is the same formula. So 3 divided by, that is the relevance score, divided by log I plus 1 to the base 2. So 3 divided by log 2 to the base 2 plus 2 divided by log 3 to the base 2. In just now I told how to calculate. So this formula itself we are using. Okay, so 3 divided by log, since it is the first document, so 1 plus 1, so log 2 to the base 2 plus 2 divided by, okay, so 2 plus 1, 3 plus, this is the third document, so 1 divided by log 3 plus 1, which is 4, plus 0 divided by log, it is fourth document, so 4 plus 1, 5 plus 0 divided by, it is fifth document, so log 5 plus 1 to the base 2. So 3 by log 2 to the base 2 is 1, log 3 to the base 2 is 1.585, and log 4 to the base 2 is 2, 0 by anything is 0, 0 by anything is 0. So 3 plus 2 divided by log 3 to the base 2 is 1.585, 2 divided by 1.585 plus 1 divided by 2 plus 0 plus 0. So 3 plus, simplify this, 2 divided by 1.585, I'll get 1.26 plus 1 by 2 is 0.5. So IDCG is 4.76. Okay, now let us calculate normalized discounted cumulative gain. So NDCG equal to DCG5 divided by IDCG5. So NDCG, we have come across that the discounted cumulative gain is 4.67 and IDCG is 4.76. So NDCG means 0.98. So we came across this normalized discounted cumulative gain is going to be 0.98. So this is how we will be calculating the relevance. So here it is a metric that evaluates the quality and recommendation of information retrieval system that compares ranking to an ideal order where all relevant items are at the top of the list. So given any document, the main motive of this video was to tell you about how to calculate the normalize discounted cumulative gain for any given set of documents and with their relevant scores. So with this note, I'll be ending the video. Thank you. Please keep sharing this video to everyone.